Okay, so let's dive into this really fascinating new paper. It suggests a completely different way to think about how AI models read long documents, like entire books or huge code bases. And this method, it could seriously change the game for both how accurate and how efficient these models are.
So, think about this for a second. What if an AI could actually learn from a book just by reading it, the same way you do? That's really the core question behind this new technique. Instead of just trying to perfectly recall every single word, the goal here is to make AI learn and compress information in a way that's much more, well, human.
But, before we get into the solution, we kind of have to understand the problem. And it's a really fundamental challenge that AI has been wrestling with for years when it comes to long texts.
Right now, you've basically got two main options. On one side, you have your full attention transformers. These things have a flawless photographic memory. The problem? The cost, both in time and money, just explodes the longer the text gets. It's not sustainable. On the other side, you've got models like RNNs. They're super fast, really efficient, but they tend to get lost. They lose the plot in really long documents. So you're stuck, right? You have to choose between perfect memory and practical speed. You can't have both. So what if we just change the goal? What if we stop chasing this idea of perfect, lossless recall and aim for something that looks a lot more like real understanding? This quote from the paper just nails it. The authors are saying, look, it's not about memory, it's about learning. You don't remember every single word from some lecture you had years ago, right? Of course not. But you compress the key ideas into an intuition that you can still use today. And that is the goal here, compression, not just memorization. And that brings us to the big idea, test time training. It's kind of what it sounds like. It means the AI model isn't just a static, finished product. As it's reading a new document, at test time, it's actively learning from that document. It's continuously updating its own parameters, its own brain, to compress the context it's seeing in real time.
Okay, so how does this actually work? Let's pop the hood for a second and see what's really driving this new kind of learning process.
So to really isolate the effect of this technique, the researchers did something pretty clever. They took a transformer and basically gave it amnesia. They stripped out its attention mechanism, the very thing that gives it a memory. Without it, this model can only see one word at a time to predict the next. It has zero long-term memory. It's the perfect blank slate to see if test time training can give it.
So as the model reads, it's in this constant loop of self-improvement. For every single word, it tries to predict the next one. Then it looks at the right answer, sees how wrong its prediction was, and uses that error to make a tiny tweak to its own internal weights. So by the time it gets to word number 2, it's already learned the lesson from word number 1. It's literally learning on the fly, one word at a time.
And this is where the end-to-end part comes in. The secret sauce is something called meta-learning. See, the model isn't just thrown into this. It's pre-trained from the very beginning to be an absolute expert at this exact skill of learning at test time. So it's not just learning content. It has actually learned how to learn efficiently from new information.
All right, so that all sounds pretty cool in theory, right? But does it actually work? Let's look at the results and see how this new approach really stacks up against the old guard. And the results are, well, they're pretty staggering. This table shows us the test loss, which is just a fancy way of saying how many mistakes the model makes. Lower is better. And would you look at that? TTT E2E is right there with the gold standard full attention transformer. In fact, it's even a tiny bit better, even at a massive 128,000 token context. It takes a simple architecture and makes it a top performer. But here's the kicker. This is where it gets really wild. While the full attention model's processing time just skyrockets into the stratosphere as you give it more text, TTT E2E is a flat line. It stays completely constant and low. It doesn't care how long the document is. It just chugs along at the same efficient speed. To put a number on that, at a 128K context window, it's nearly 3 times faster than the full attention model. And that's not just a small improvement. That has huge implications for the cost of running these models, which is one of the biggest bottlenecks in AI today. So this isn't just some minor incremental step forward. This new way of thinking could genuinely unlock a more efficient, more scalable future for AI. Now, it's not a silver bullet for absolutely everything. On these needle in a haystack tests, where the whole point is to find one tiny random fact buried in a mountain of text, well, the full attention model is still king. TTT E2E really struggles here. And honestly, the reason it struggles is what's so telling. It's designed to compress and get the general meaning, so it sees that one random piece of data as noise and just filters it.
And that really highlights the fundamental difference here. This approach is designed to work like a human learner. It's built for compression, for building intuition, for understanding the gist of something. It's not trying to be a search engine with perfect lossless recall. It's all about prioritizing understanding over just memorizing every single word.
So, what's the bottom line here? First, this reframes the whole issue. Maybe long context isn't an architecture problem, it's a learning problem. Second, you get the holy grail, top-tier accuracy at a low, constant cost. That's huge. This makes scaling AI to massive context way more practical. And finally, it points to an AI that's more human-like, one that learns by compressing experience. Now, it is important to point out that while using the model is way cheaper, the paper notes that training the model this way is currently slower. So that's a key trade-off for developers to think about.
And that really leaves us with a fascinating, kind of mind-bending final thought. This whole method just blurs the line between training a model and using it. So if an AI can learn and adapt continuously from everything it reads, what does it even mean for a model to be fully trained anymore? It's a question that could totally redefine how we build and think about AI from here on out.